This episode of the HVAC School podcast is made possible by our sponsors, Testo, Carrier, and Rectorseal. And so for these companies, Carrier, Testo, Rectorseal, that partner with us, I want to just remind you that means that they're the ones that make this possible. This podcast, the daily tech tips that we send out via email and post online, the Facebook group, the Facebook page, everything that we do, as you've probably noticed, we produce a lot of content here at HVAC School. We put out a lot of stuff. And the idea is that we're gonna kind of trickle it out to technicians, so you get a little bit of something every day, something that you can kind of think about or chew on. It's a little easier for you to get it that way than it is to get it in these gigantic books. It's hard to sit down and read, say, for example, refrigeration air conditioning technology, even though it's a fantastic book because it's so much at one time. And so these sponsors, Testo, Carrier, Rectorseal, they're the ones who really make this thing go. And of course, also, recently we've had Parker and the Zoom Lock tool come on, and you're going to hear a little bit more about that in just a second. For those of you who are in the industry and you see these tools or you see these products, don't discount the fact that they're making an investment in you and in the industry by partnering with us. I couldn't do this for free the way that I do if it wasn't for these brands who partner with us and make it possible. So hats off to them. I believe in these products. I believe in these companies, and I'm very thankful to them for partnering with the industry, because through HVAC School, they're helping solve the single biggest challenge that exists right now in the HVACR industry, which is the skills gap, and helping improve the skills of technicians and those who are coming into the field. So thank you, Carrier, Testo, Rectorseal, and Parker Sporlan. One other quick announcement that I forget to tell people a lot is that our website is hvacrschool.com, and you can go right to the homepage and search any topic we've ever discussed on the podcast and any of the tech tips right there on the homepage now. It's super easy. So if you have something that you want to figure out or read about or learn about more, just go to hvacrschool.com, look for the search bar, and search it right there.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
And now your host, the man who once used too much coil cleaner and took the coating right off a Lennox coil, Bryan Orr.
I am Bryan, and this is the HVAC School podcast, and I am nothing if not an ambitious cleaner, or at least early on in my career. I started my first job as a technician when I was 17. I mean, technician, loosely a technician, I guess. I was in my own truck when I was 17, and I did a lot of maintenance, and I really liked to use the coil cleaner just to see the bubbles. And that was definitely a mistake, especially in the case of that particular Lennox unit. But I learned my lesson from then on. And yeah, today I really don't suggest that guys use cleaner unless they need to. So anyway, today on the podcast, we are going to be talking with James Bowman. James has been on the podcast before. James is the national training manager, national training guy, goes around the country training people for Rectorseal. And I like James. He's a real down-home guy. And he was talking at the HVAC Excellence Conference about the need for condensate switches even on ductless systems, which kind of makes sense. I mean, anything that makes water, you need to have some way to take care of that and prevent it from draining all over everything if the drain line or drain pan are to back up. But there's actually some interesting codes in the International Mechanical Code about this. And so we're going to talk a little bit about the International Mechanical Code and what it has to say about condensate switches, condensate drains, all that kind of stuff. So today is really a conversation about condensate switches, which seems like a pretty simple conversation. And I guess it is, but there are some nuances there. So here we go. James Bowman from Rectorseal. So the first thing I wanted to talk about, I think the easy, we'll start with the easy conversation, and we'll get into the more difficult ones once you're warmed up. First of all, are you prepared to talk about the whole float switch thing?
Yeah, I can talk about whatever you want to talk about.
Yeah? Well, I have 3 things on my list.
Okay.
Remember what they are?
No.
I see, that proves your preparation here. That shows your commitment to the HVAC School podcast, James. I need nothing but complete commitment and dedication to what we're doing here. But I do have iced tea, so that's good. Do you have your iced tea?
I have my iced tea.
I was going to say.
I filled her up.
Yeah, so I'm sitting here at my desk here at HVAC School HQ, surrounded by test instrumentation, buzzing and humming all in the background. You can't hear it, but in front of me I've got my very off-brand, not so great sweet tea, but I'm drinking it in your honor, so I hope you appreciate it.
That'll work. Mine's probably a mixture anyway of stuff.
What kind of stuff we talking here? Like
Well,
vodka,
I'm
tequila?
I'm supposed to cut back on the caffeine. My cardiologist has informed me of that, and so we came to an agreement. But I also have to stay hydrated. So I drink a lot of decaffeinated tea, but I drink some caffeinated. So it's a mixture.
I'm glad we have some caffeinated so that way you don't fall asleep on me like you tried to do in the last one.
I did go out to lunch.
Oh, boy.
I was going to go out to lunch, and then a buddy of mine called and said, "Hey, I'm available for lunch." So I was like, "Okay, let's go." We had chicken gizzards. So, yeah, I'm a little sleepy. You have a
Chicken
yawn
gizzards.
button there, right? Oh, I love chicken gizzards.
Really? That's something I have never indulged in. And we actually have a place that serves them right down the street called Crispy's Fried Chicken. A little mom and pop, grody little place, grease on the floors, and they make some good stuff, but I've never tried the chicken gizzards. Of course, I don't even know if I'm a real Southerner because I don't know if I told you this, but the first time I ever ate pork rinds was just a couple months ago.
Yeah, I don't eat pork rinds.
Oh, okay, well that's good. Well, I thought you were going to rip me for being a fake Southerner.
Well, I was not born here or raised here. I just got here as fast as I could. I was actually raised in central Indiana, but Uncle Sam brought me to Fort Hood I don't want to age myself here, 89. But I've been in the South ever since, Florida and Texas ever since 89.
God's country.
And the best places to be if you're in the air conditioning business. True.
First thing I want to talk about with you is I didn't realize how complicated, we'll call it float switchology, condensate switchology is. It's quite an interesting science. So I'm going to kind of guide you because you let me know that you didn't come prepared with your code book in front of you. But the first thing that I want to address is something that you brought up at the HVAC Excellence Conference, which I thought was a good point, is this whole thing that every type of air conditioner requires some sort of condensate overflow switch, and that includes ductless systems. So would you care to talk about that a little bit?
Well, the code that's being referenced there is, and I'm going to paraphrase here, if you have a coil, a downflow coil or any other coil that does not have a secondary drain line or port, and it's not feasible to install a drain pan, then you have to have a sensor inside the primary drain line, or drain pan, So if I've got a downshot rooftop unit, there's no secondary port, and there's no place to put a drain pan. But if it overflows, it goes straight down into the building. So you have to have a sensor in the pan. If I got a mini split hanging on a wall, you don't have a secondary port, and where do you put the pan? You don't. So you have to have a sensor inside the primary drain pan.
Yeah, that would look pretty awkward, putting an auxiliary pan underneath a ductless system.
I've seen it.
Have you? I bet that looks great, especially like if you had a cassette unit or something, that'd look especially good. Just hanging right underneath it. So I'll read the code because I'm looking at it right here. And so the first thing that I want to mention is that whenever we're referring to these codes, generally we're referring to the IMC, the International Mechanical Code. And the International Mechanical Code is not the law nationwide, but it is widely adopted. And so no matter where you live, if a code is enforced, there are some places that don't even have, mechanical licensure for that matter. But in general, if there's a code that's in force, it's usually a derivative of the International Mechanical Code. So even if this isn't the code where you're at, it's likely that at some point in the near future, this will be the code. So did I say that right there? Did I miss anything?
No.
In reference to the IMC?
Yeah, some states are very proactive and keep up pretty quick. Other states may be, the code cycle is every 3 years. So the current code is 2015. The 2018 is supposed to come out September, I think, is when they're going to start selling it. So some states are still on 2006. And then some states will actually use either alongside the IMC or as a standalone the uniform codes, which is a different code organization called IATMO. And, some of the codes there are a little different in they're less detailed and give a lot more often it says, or per the
manufacturer specs.
That's what they're saying. My mind went blank all of a sudden on the actual term, the authority having jurisdiction.
Right.
So instead of saying you have to have this, it'll give a brief description and then followed up with, or per the authority having jurisdiction. So it gives a lot more leeway to the code official. And then, of course, you got states like Florida who will base their codes off of the ICC codes, but they adopt it as the Florida Building Code, and they go through and do a lot of amendments. So even if you're looking at the international code, we still have to go, if for your area, you have to go to the Florida Building Code and see what actually was adopted and amended for your state.
Right. You have to actually look at the Florida Mechanical Code is what I've got this big book sitting on my shelf right now. But by and large, if you know the IMC, the International Mechanical Code, you're going to usually be pretty close. And this is different for those of you who are used to the National Electrical Code, the NEC, put out by NFPA. That's essentially nationally recognized. So electricians it's much more nationally recognized. It really is the authority on the subject. Whereas the IMC, it is a authoritative work, but it isn't enforceable. It's not enforceable nationally. Every individual state, every individual municipality in some areas has to take it and say, well, we're going to accept it in full, or we're going to amend it, or whatever the case may be. So I think that kind of addresses it. So when I read this code, I just want to say that even in Florida, and I haven't read the Florida version of this, which is kind of silly that I haven't, but this is going to be widely enforced across the country, and it may not be enforced where you are, but in general, this is going to be what most people adopt. And the code is 307.2.3.1. That's kind of easy to remember, I guess. On downflow units and all other coils that do not have secondary drain or provisions to install a secondary or auxiliary drain pan, which means it doesn't have either an auxiliary drain pan with its own drain or a secondary port, an auxiliary port on the primary drain pan. A water level monitoring device shall be installed inside the primary drain pan. This device shall shut off the equipment served in the event that the primary drain becomes restricted. Devices installed in the drain line shall not be permitted. And it's that last bit there that gets kind of confusing. So I want to see if you are willing to address that, which is that devices installed in the drain line shall not be permitted.
Well, in that case, what happens is, and the reason that says it on that particular is, if you have a stoppage, a lot of stoppages are in the pan itself. Well, let's take mini splits, for example. Mini splits may sometimes use a pump. And if a pump has an interlocking secondary or safety circuit, the purpose of that is not to protect from property damage. It's simply to turn off the unit in case of a pump failure. And many times what happens is the filter or the reservoir on these things gets plugged up, and the pump never knows that a unit's making water, so it never comes on, it never shuts it off, and you have overflow. And that's located in the drain line. So that's the purpose of that. How many times do we go up on rooftops and you've got stoppages, maybe in a trap or something? Why they put that in there for rooftops, I really don't know, but that's one of the main reasons is junk in the drain pan will stop it up.
So the thinking is you want some sort of protection that regardless of whether it's the drain line that backs up or the drain pan that gums up, that it's going to shut the unit off. That's the point. And if you install, so let's look at an application here. Let's say you have a situation where you have an RTU and somebody takes a float switch and wires it in the drain coming out of the RTU and just takes that and wires it into the unit. And they say, it's 24 volts. It's fine. It'll be okay, right? So they just leave that there. Well, that's not code because it's in the primary drain and there is no other secondary provisions like an auxiliary drain pan or a secondary drain or anything like that. So that's not allowable. In a ductless system, you can't just rely on the float switch in the reservoir. If you have a pumped application, you can't rely just on that, because if the actual drain pan itself gummed up and started overflowing, that wouldn't prevent property damage. And so what they're saying is,
without redundancy, you're going to have damage a lot faster. Let's take the Florida market. The Florida market is very big on upflow in closets with no secondary drain line or secondary drain pan. Well, probably more property damage in the state of Florida from condensate than anywhere else in the world, because there's no redundancy. If the clog doesn't trip the switch or the switch fails, there's no secondary pan, and hence you have property damage. So by having a switch in the primary pan, it's going to react a lot faster than anywhere else that you would have a sensor. So, hopefully it'll react fast enough and prevent damage.
So what the code isn't saying is it's not saying that if you have let's say you have an upflow. So I'm in Florida, so we work on these units every day. You've got an upflow. It's got a secondary port on the drain pan, and that secondary port is either higher than the primary drain, or it's got a hole drilled in it, some sort of a dam built up in it, but some way that it only trips if the water in the pan raises, and then it flows into that secondary port. I mean, we all know what this is like throughout the country. This is pretty typical stuff. If you install your float switch in that secondary port, that's essentially installing it in the drain pan. That port is just an extension of the drain pan. It's just giving you a place that you can install one. So that is an acceptable method according to 307.
And if you back up to 307.2.3, it actually has 4 ways of complying with the code before we get down and talk about downflow and coils that don't have it. These are typical unitary equipment. So the first being an auxiliary drain pan with a separate drain under the coil, discharging to a conspicuous point of disposal.
So that would be like the old, you have the secondary drain pan, and then you have a drain connected to that, and then that drips up above a window in the soffit or something so that you can see that it's dripping. And
that section lays out the minimum requirements for drain pans. The thicknesses of the material, the size of the pan has to be minimum 1.5 inches, no less than 3 inches than the size of the unit. The thickness of the steel and the plastic, if it's a plastic pan. Then next, go down to section 2, it tells us a separate overflow drain line shall be connected to the drain pan, which is provided with the equipment, which means that you take your secondary port and actually pipe it out.
So that's one acceptable method, basically.
That's one acceptable method. Now, once again, this is in the international code. Now, once you get locally, some of these apply, some of these don't apply. Depends on your local amendments. So then the third is an auxiliary drain pan without a drain line, but with a switch in the drain pan.
Yeah, you got a unit sitting in an attic, usually horizontal, secondary drain pan laying underneath it, and a switch in that secondary drain pan, so if it fills up, it trips. Right. And then you end up having to shop vac out like 50 gallons of water.
So here in Texas, you have to have the pan piped out and the switch.
Which makes sense.
Which makes sense, unless you're in a location where there's just no way to pipe it. Fur down area where water would have to go uphill to run out from a pan. In those cases, they'll allow it. And then the fourth is in the drain line, the overflow drain line, the primary drain line, or in the primary pan, like the secondary port. I believe Florida has amended that to delete the section that says the primary drain line. I think they allow it up in the panhandle, but everything else, for some reason, they don't allow inside the primary drain line.
Wait a second. So under what circumstances could you only have a float switch in the primary drain line?
Well, I'll read the section. Okay, it says a water level detection device conforming to UL 508 shall be provided that will shut off the equipment served in the event that the primary drain is blocked. This device shall be installed in the primary drain line, the overflow drain line, or in the equipment supply drain pan, located at a point higher than the primary drain line connection and below the overflow rim of such a pan.
Above the primary drain line connection. Oh gosh, that's confusing as heck.
It is. So what that's basically saying is you can put the switch in the primary drain line, in the secondary drain line, or like an SS2 in the secondary port of the primary pan. That's what that section allows. But I believe that the majority of Florida does not allow the primary drain line.
I'm just confused about what that means then in 307.2.3.1 when it says on downflow units and other coils that do not have secondary drainer provisions.
Because at that point, you're only dealing with downflow units and all of the coils that do not have a secondary drain or pan. So on units
I see what you're
don't have a secondary port. Rooftop package units have a primary port but no secondary port.
Okay, and so if it has, all right, so the only case that you could put it, according to the IMC, the only case you could put it in the primary drain pan, the switch, is if you have some other secondary method, like a secondary drain pan or a secondary drain line in addition to that then.
Correct.
Got it. Okay, that makes sense. All right. You educated me.
Now, while we're on this section, let's go back to this requirement of UL 508. This was added in the 2006 code cycle. And to this day, there are still lots of switches being sold that either do not comply with 508 or are not listed to 508. And that I find kind of funny. I mean, in a way. The easiest way, of course, UL listings, the standards are, 100 pages long, but I'm going to boil it down into a sentence. Take a float switch, apply your 24 volts to it, and drop it in a bucket of water. If nothing shorts out, it probably complies with UL 508. If something shorts out, it doesn't comply with UL 508. That's the easiest way.
Yeah, and that makes sense. Like, I remember some of the older float switches that were out there that had these, like traditional micro switches almost on them, that and those you would think wouldn't comply because they had these kind of open.
And they don't, but they're still being sold, even though, they don't comply and haven't been complying since 2006. And the other part of it is there are companies that sell float switches or condensate switches and sensors that instead of actually paying UL to test them and getting the listing, they put on their tag conforms to UL 508, but it's not listed. So,
right.
What they're basically saying is trust me. We didn't ask a third party to verify our claims, so trust me. Oh, and by the way, yeah, we're a little bit cheaper. So, there's another, but...
James, I'm sure they did the drop it in the bucket of water test.
I'm sure they did it. I'm sure they did. And it's very possible and probable that if they sent to UL and they had them tested, that they would pass and they would get their listing. It just costs money to do that. So
costs money to play by the rules, doesn't it?
Yeah.
I think all of us contractors know how that is.
Oh, yes. So I always find that interesting. And when I've asked code officials about it, they're like, well, if the manufacturer says, but yet other inspectors for other products will say, I got to see your UL listing or your UL sticker. It's just one of those things that's just kind of ignored by inspectors.
Well, in this particular case, it's a standard that makes sense. I mean, you want your condensate overflow switch to be as reliable as possible, and you don't want it to be affected by moisture and water. I mean, clearly, it's in that environment. So if you have a drain that's backing up, I mean, I've seen them back up right up into the micro switch itself. You don't want the thing to fail just because of some moisture.
Well, that requirement was added because of the sensitive electronics. We're basically taking 24 volts and connect it to a very expensive circuit board, and we're sticking it down in water. So that's why the listing is there. That's why the requirement's there. It's to protect all that sensitive electronics that are in these systems now.
Cool. So one thing that I want to talk about, I don't know if we haven't talked about this beforehand, so you may tell me that you don't like my way, or you don't like the way that I address this issue. So tell me if I say anything that is offensive here. But the one thing that I get a lot is the controversy, and I wrote an article about this, that surrounds how to pipe a auxiliary float when it's in the auxiliary drain line. So how to pipe it out of that auxiliary port and how to position it. And so you have two camps. You have the one camp that swears that if you pipe it straight out the front of the unit, that it's not going to work. And then you have the other camp that swears that that's the only way to do it. And if you pipe it around the side and drop the level down lower, that it's not going to work. And my stance on it is that depending on the unit, that's how you need to make that discernment. And I shared a picture in the article that I did where there's two different units, and the levels between the two, the depth of the drain pan and the level difference between the auxiliary and the primary are pretty radically different between these two units. Some of the less expensive brands out there, often they'll just take the secondary port and they'll just drill like a hole towards the top of it. And in some of those applications, you may run into a circumstance where the drain pan overflows before the float rises high enough to shut the unit off when it's piped straight out the front. The first thing I want to ask is, have you ever seen cases like that, or have you ever heard that?
Absolutely. In fact, see, what happened is over the last few years, several manufacturers have started redesigning their drain pans, particularly in the vertical application, okay? The primary reason is to try to not allow any standing water in the drain pan whatsoever. All the water would drain out during the off cycle. And part of it is to cut cost, because let's face it, you pay for plastic by weight. So, if you've got a pan that's got an extra half an inch height all the way around it, then you've increased the cost of that pan. It has nothing to do with the design. It just has to do with how much the weight of the plastic you put into it. And you're making millions of units. So we actually, a couple of years ago, changed the float on the SS2 to accommodate one of these manufacturers that had made that change. Since then, 2 other manufacturers I've been aware of have also made that change, and we're running into that as well on those. And a lot of people forget, installers love them. I was an installer. You got to read the instructions, guys, plain and simple. You got to test before you leave the job. All safety switches are adjustable. 100% of all of our safety switch models are adjustable. If you need to adjust it to lower the float because you have one of those pans, please do. If you need to pour some water in, as we point out in the instructions before you leave the job to verify that it actually works with your application, please do that as well. It will save you problems later. So the answer to both of those methods are yes, do either one as you need to do. If you've got one of those type of pans that is so small that you're finding your switch is not sensitive enough, move the switcher around the corner, drop it down a half an inch. Or, if you've got a pan that's not as sensitive or holds a little bit of water, you want to stick the SS2 right in the front of it, do that. I mean, it's not a cookie cutter approach.
Right.
And
you want to verify. You want to make sure that you install it properly, and you want to verify that you've installed it in such a way that it's going to function. Once that drain pan fills up with water, and regardless of where the blockage happens, that's what's going to occur, whether the blockage is in the pan or in the line, the pan's going to start filling up with water. You want to make sure that it flows out that secondary port and ends up filling up that switch high enough that it trips the float. I mean, it's really that simple. It's not rocket surgery, as they say.
Another thing that is often overlooked with condensate switches is, let's think about heaters. Okay, with gas heaters, propane, natural gas, fuel oil, even electric heaters, you have safety switches. You have limits, rollouts, in oil, there's a few more. And every fall, when you go to do your heater check, you test those safeties. Many times I ask guys, what safeties do you check in the spring when you go and do your air conditioning preseason? Well, hence, that's one of the reasons called a safety switch. Because it's a safety.
Right.
Test the switch. Make sure. Don't wait until you have an overflow. And as in the case of Florida, the snowbirds are gone for the summer and they don't know for 3 months that they've had water overflowing, that they had a problem. Test your safety.
Yeah, I mean, it's not that hard to do. And that is actually something that we practice, is testing the float. I mean, where we are, though, it's so mission critical. There's nothing worse than having that call in the middle of the night where there's water pouring through someone's ceiling because they have a second, an air handler sitting on the second floor and it's backed up. Float didn't work for whatever reason. And in most cases, when the float doesn't function, it's usually because of installation issue, where someone, pitched it was running around the side and someone pitched the pipe up because they were like, oh, this thing keeps, this is the most annoying one that I hear. So this is one that I just want everybody to stop saying, where they have it connected to the auxiliary port, and then they say that, well, it's going downhill, and that's why it's filling with water. No, it's filling with water because water is coming over the dam on the auxiliary port and ending up in that pipe. The only way for it to come in that auxiliary port and end up in that pipe is if the water level is getting too high. So the pitch of the drain going downward away from the unit is not going to result in water in that pipe. If water's in that pipe, it's another problem. And I have guys argue with me about this all the time, but it's really pretty basic stuff.
And with the prevalence of ECM motors now, I find very often that the problem is static pressure.
Right.
They get too high static. They slap in a new system on an existing duct system without evaluating it, checking their static. And now you're trying to move so much air through this thing, you've got all kinds of things happening, including water, being blown off or sucked off and landing places it shouldn't be landing.
Right. Yeah. What tends to happen, one of two main issues. One is that sometimes the primary drain will lose the seal of its trap, and so then it's sucking air back in the primary drain, which results in water going in the secondary. And then another thing that can happen is whenever you have really high static, you have air bypassing all sorts of places that it's not, with decent velocity, that it's not supposed to bypass. And all these little air currents can result in water ending up in that secondary drain. It's not just the static pressure itself that causes it. A lot of guys kind of have this vision in their head of, oh, well, there's all this suction, and so it's just sucking into the auxiliary drain. It's in fact that there's just air that's going around every crack and cranny and crevice, which can result in, water being either flipped up, kind of flicked up into the secondary drain because there's, the water is almost getting little waves and eddies in it. Or in some cases, you can actually lose your primary trap, depending on the design of the trap, design of the system. In fact, if you look at like Carrier's specs, it will show you as you get up above, and most of them I think it shows up above 0.7 or 0.8, it'll start to say that the system will have a hard time maintaining a trap seal once your static pressure gets above that.
You've got it. You hit the nail right on the head.
All right, so, well, thank you for saying so. I appreciate that. I always need the emotional affirmation. I'm sort of a sensitive little fella. You've probably caught on to that.
Yeah, I sometimes twist something or hurt something, patting myself on the back, too. So,
yeah. Yes. Sometimes you hurt your own back trying to pat yourself on the back.
Yeah.
All right. So what products does Rectorseal make in the, because the one thing that I think very few technicians practice is the installation of a float switch in the primary drain. So lots of guys will use pan switches in secondary drains. Lots of guys will use them sometimes even in the primary drain, even in cases that isn't quite in compliance with this code. And a lot of times they'll use them on the auxiliary port, but I see very few people putting them in the main drain. So what are some of your favorite products for that?
Well, the SS1 is the most popular for the primary drain line, the safety switch SS1. That also complies with another section of the code that says that you have to have a means of clean out without cutting the drain line, because the SS1 itself is a clean out port, and it comes with a little handy clean out tool. We have an Easy Trap product as well, that EasyT226, I think. I'm going to look at it just because I've only got 1,500 products that I can't remember. The 225 is the equivalent of the SS1, and the primary differences between the two is the SS1 has a reed switch, the EasyT225 has a micro switch. But all 100% of our switches, whether it's a safety switch, an AquaGuard, or an Easy Trap, are all UL listed to 508. So they're all designed in such a way that they've got that extra safety measure on there.
Okay, so that's the primary drain, which is what I said, but not what I meant to say.
Okay.
So what about the primary drain pan? What are some of the products that you recommend for the primary drain pan?
Well, the SS3 is small enough to fit in a lot of them. Then we have our SS500 is designed specifically for rooftop primary drain pans. It's plenum rated. It's an electronic switch. It will also fit in the primary of a unitary. For our mini splits, we have the SS610E that will work with mini splits.
And so that goes right down into the pan of
into
the
primary
mini split.
pan. Two different ways to attach it. You've got a little clip that clips onto the coil with a little plastic. I don't even know what you call the thing. It's just a little piece of plastic that you can drop it down into the pan. Or we also have a very small clip that if you've got the space that you can clip it onto the edge of the pan. What else do we have? We've got...
First off, both of those use like almost it's an electronic switch, but it's almost like two little electrode points.
Right.
That when the water level rises, it bridges between those two electrodes, and then that's what trips it, right?
Yes, correct. And the beauty of our safety switch electronic switches, we actually have 3 LEDs on them. Because one of the things, you've had these calls, I've got this nuisance trip, I've got to manually reset it, or you show up and she's like, it came back on, check it out anyway. So we've got a red light that says, hey, I got a drain problem, I got to shut off. Green light, it's not a drain problem, don't have it shut off. Yellow light, I've had a drain problem sometime in the last 4 days.
Oh, got it. That is nice.
So you got a slow drain. You see the yellow light, you got to check it. We have a couple of 3180, an AquaGuard 3180, that's the one. That's also for rooftops. This is actually, down in your area, there's a lot of residential high-rises up and down the coast of Florida that use water source heat pumps, in those units. And water source heat pumps are very unique in their design, so putting a switch in them can be a little challenging. They're package units, so they only have a primary port. They don't have a secondary port. Most of those pans are only 1 inch tall, but yet if you have an overflow, it might not just affect you, it might affect 11 floors below you.
Right.
So the 3180 is actually the perfect switch for those water source heat pumps in those high rises, because you have two sensors. One of the sensors is a small clip that will fit in the primary pan. The second one is larger, but you can put it inside the unit, in the bottom of the unit, on the floor, near the floor, something like that. So you got a lot of flexibility there. Plus, it's plenum rated, which is a requirement when it's in the airflow. So in a package unit where it's inside the unit, the requirement is it has plenum rated. Don't have an easy trap version that goes inside the primary pan.
I guess the main thing is just for techs to recognize that these products exist, that they work. They do have to be adjusted. So you have to pay close attention to the probe placement because you're dealing with fine tolerances, especially like with a ductless system. So you can't just go in there haphazardly and just jam the thing in there. You got to really think about where to set those probes so that way they don't trip under regular circumstances. But if the drain starts to overflow, they do. So you got to think about some of these things. But it makes a lot of sense. I mean, we've seen ductless systems for years before we started thinking about these things, before we started putting these in, where we would have these backups and they would leak on someone's, television, or they would leak on someone's computer or whatever. And that's a pretty significant issue. And you can have property loss and everything else. So it's just common sense that you would want to have something in there to protect the system.
And, the two things that, if I could reach every single technician, there's two things about condensate switches that I really would like them to think about. And sometimes it's more business owners than the technicians. But number one is redundancy. One switch, particularly in high humid areas like along the Gulf Coast, in Florida, and particularly in homes that are unoccupied for long periods of time throughout the year, a single switch may not be the only protection you need. Take the time, get a custom pan built, put it underneath the unit, put a hockey puck type of switch like the SS700 underneath the unit, so that if you have a failure or if you have water that drips down, you still have production. So think about redundancy. And then also think about, there's no such thing as one size fits all. There's no way possible that one switch will work in 100% of every application that you see. That's why there are lots of choices. So think about each and every job. Think about what the application is, the lifestyle of the homeowner, look at everything. And then choose, well, you know what, in this case, I may need a different switch. It's such a small thing, but we've all seen what happens when that little small thing doesn't work as you thought it would.
Yep, and you made a good point about the adjustment, too. So redundancy is great, and then also pay attention to the adjustment on these things. Because, for example, if you're putting an SS1, say, in a primary drain line, you're going to want to be careful not only that it's adjusted properly, but in that case, you're going to want it to be a little higher because you don't want that float sitting down in the actual water stream. You don't want it sitting there so that every time it's draining under normal conditions, you have water running over that float, because it's going to tend to gum the float up and actually cause the drain to back up prematurely if you have it too low. Whereas if you have it in the secondary drain, you really want to get it as low as you can, because in the secondary drain, there shouldn't be water in there unless there's an issue. So get it lower, and then that way it'll trip a little sooner. So the application even makes a difference on the adjustment.
Absolutely.
Cool. Well, thank you for this, James. I think it's helpful. And for everybody out there, obviously Rectorseal is they're a sponsor of the podcast. They partner with us. They make great products. I've been using the safety switch products for years. I mean, it's really almost all I've ever used. And they've always done the job for us. And all we average 3-4 installs a day this time of year, and we put them in every system, and they work great. So thank you for doing what you do, and we will talk to you again soon.
Oh, I appreciate you, Bryan. You're doing a good job.
Hey, thanks for listening all the way to the end of this podcast. I appreciate you. If you don't subscribe to the podcast on an app, I would suggest that you do that. So you can use the Stitcher app. If you are an Android phone, have an Android phone, you just download the Stitcher app, subscribe there. If you have an iPhone, use the podcast app. I would also ask that if you know somebody who you think would benefit from this podcast, actually show them how to download this on their phone, because people really struggle with this. People who don't listen to podcasts, they don't understand what it is, and they think it's something difficult or confusing, and once they find out that it's not that bad, they'll hopefully enjoy it. So if you can grab one of your coworkers, grab their phone, show them how to listen to a podcast, you would do them and me a great favor. So thank you for listening. We have some good episodes coming up pretty soon. I've recorded a few more with Jim Bergman. So those are going to be coming out soon. Jim has a big announcement that's going to be hitting the marketplace here in the next few weeks that we're going to talk about. That's going to be huge. But in the meantime, hey, do some good work, why don't you? Thanks for listening. See you next time on HVAC School.